Hello and welcome to droidcon Berlin Day 2. I'm so happy that you chose to start your day in the cold Berlin summer weather with talk about UI testing and especially about automated regression. A bit about me. I'm an avid Android user since the first versions, so I'm passionate about app quality there. And I'm a Kotlin aficionado, so I really love everything about it, and I think it's the best thing that happened to Android development. I'm a big fan of bouldering, and I'm a bit of a meme advocate, so sorry about that. And as well as I'm a senior engineer and focusing on trading experience in Trade Republic right now, which is easy to remember. Now, today the talk would consist of a couple of sections. First, we talk about context, as everything starts with context in Android, and then we talk about how to set up your UI test, how to interact with UI, and also what to do with the network, and briefly touch on stability, infrastructure, and reporting side of things. So context, or in other words, why we needed automated regression testing. So I'm not sure if you know or not, but when I joined, we kind of moved from the old UI to the new one. But more importantly, we moved from one kind of neo-banking product to neo-broker product to a neo-banking product, which is much of a broader scale. And it is a scale-up, so we have to scale everything. So one of the parts is like, OK, we have a trading as a core product. We have a relatively small team. Then the regression time is kind of reasonable. And we can just store everything, manual test cases in Excel. And then we can release comfortably every 2 weeks, and it's fine. Now, when we scale it up, we have multiple equally important products, relatively large Android team, now more than 30 people. And then we also have estimated manual regression time over 2 days. And then at least we store them in a proper test case management tool now. But the thing is, we want to release every week. So how do we actually do that, given the regression, which is the word that is not really fun, even just to say, but actually do it every single week. It would be exhausting. So let's maybe try to automate it. And first, we need to talk about what do we actually want to test when we cover it with the regression. So essentially, we have other tests, right? So we want to test that our feature works the same way that we expect it to work in integration altogether, right? And then it means that we want to test all of the interactions, all of the journey the user can make, including edge cases, and also a core stuff like app startup, logic, navigation, network, storage, deep linking, and so on, right? What are we not testing here are things like visual representation of the component on the screen, or like formatting, localization, or like intermediate states that we know that they're going to resolve to something else. We could potentially introduce some flakiness in our tests, and as well as artificially slow it down to test some poor network conditions, right? And if you take a look at the developer Android example for UI testing for Compose, you would see something like this. Actually, you would see exactly this code. And here you could see that, OK, we have an activity. We can set a content on it. And here you kind of can interact with it. But you can see that it's not really the same that what I want to test. And something is missing. So here, there is no dependency graph. There is no navigation. There is no network. And more importantly, it's really isolated, like a really small scale. And we have to do a bit of a setting up to get to the actual test that we want to make. So I suggest let's start setting up with an application. You can set up a separate test application, and then you can centralize your dependency graph. And then you can swap out some constants like a base URL or anything that you would like. And then to actually use it in the test, you need to have a test instrumentation runner. And then for us, we created it extending the Allure runner because we need it to create a folder for reporting and to actually then be later used with its tooling to send the data to Allure so we can store it in one system with our manual test cases. But this is not the scope of the talk. I'm just here about the UI testing itself. And then to create a test application component, you need to define all the dependencies. We use Anvil. It's not Hilt, of course, but it's a similar idea, and you can kind of map this to Hilt as well. So what we have as a scope, we contribute every component to it so that we can also replace it afterwards. So for example, if we need to provide this feature flag provider, we can create a test implementation, and using this contributes annotation, we can replace the actual implementation. So you could also have this on a module scope. So for example, with the whole data module, we kind of move everything that is in common to the one data module, and then we have a separate for prod and for test. Then you can have your certificate pinning set up in the proper way, and then in test you can disable everything that you need. And now, how to actually launch the app. So if you take a look at the activity, you wouldn't probably want to start the same activity all the time. You would probably start other activities if you have them. But for us, we actually have only one activity. So we need to kind of parameterize it. But there is no way to parameterize it with this factory. If you go to its implementation, it just creates an activity scenario rule using the class that you provide. And there is another constructor of activity scenario rule that you could use, but it's not exposed. So what you could do is just create your own factory and pass an intent. So for example, you can use it then to create this simple factory to just provide an URL. So let's say you have a intent with extras, right? And then also what I suggest is, okay, let's put this rule into a base UI test so it's easier to then use in the test. And then you can also centralize all of the things that you might often use in the UI testing here. And then the test would look something like this. By the end of the talk, we would create this API that it would actually work. And then here you can define your deep link. So you can open any screen that already has a deep link. And if it doesn't, then maybe it makes sense to create one, or you can pick the closest one to it. And yeah, essentially, you might have more rules because you need to set up your authorization data. Maybe you use like a common screen that is used across the app. So you would use a rule for that to kind of reuse all of the setup for it. And what I suggest, okay, let's create a factory that would provide us a rule chain with all of the default rules you might want to have in the test. And there you could have like logcut rule or something like that, like whatever makes sense for you. And then in every test, you know where to find them. Now, let's talk about how to actually interact with UI. And to interact with UI, you need to use a semantic tree. But let's first talk about scale of the test again. If you go to a UI testing code lab, you would see this tab bar component that is tested, which is really nice. But what we want to test is actually multiple screens in a flow, everything with network and so on, right? So it's a big difference in scale. So the test looks a bit different. So if you take a look at the semantic tree for the screen itself, it might look something like this. But because it's composed, you want to wrap your components around with some different kind of components, so it's more composed, if I must, right? So it's very easy to actually create the UI, but it's more problematic for UI tests because you have all of these layers. And then take a look at the item. There we have a title and subtitle and a switch in kind of one block. That means it's merged. It's used for accessibility. Imagine if you have a screen reader and then needs to go through all of the components. For its users, it makes sense so that you can read out the whole row instead of just reading elements one by one. But for UI testing, you might want to click on the switch. So to do that, you need to use unmerged semantic tree. So you have to always make a decision, okay, what kind of tree I need to use. And then for us, because we use only one activity, we also might have multiple screens at the same time in the composition. So we have to kind of also narrow it down and find the right node on the screen. So what is actually a semantic tree node? It's essentially a metadata that Compose collects from your UI, and you can log it using this extension function, print to log. Let me clean it up. So you would see the text, the actions that you can kind of perform on this node, and also all of the accessibility labels, and so on. So if you need to kind of see, okay, how can I test my UI? Probably you might want to start with that. Or you can also use a layout inspector in IDE to check all of this information. Now, if you take a look at this sample screen, you have a home screen, you have a scaffold, and then you have a couple of items in there. It's not really testable because you wouldn't probably find the home screen in any case, because you might have multiple. So in the view system, we would have an ID, and then you can find it by ID. Here, Compose doesn't force us to do it. So we have to, for tests, we often find ourselves adding a test tag just to find this component on screen. And as well as some of the items in the scrolling containers might be big enough so that you can call them a structural component. And for us, we call them sections. And you have a section with a header, section with the favorites, and we create this kind of extension that does it for us. So here is just a simple wrap with the box and add a test tag to make it easier to then find it. And then in the home screen test, you would have something like this. You might write compose rule, our node with text, NVIDIA, perform click. You want to see the chart and latest updates for the stock price. Now, this wouldn't work because you need to, as I said before, kind of narrow it down to a specific section and the screen. So what you would have to do is write this kind of code. Okay, it's in the home screen, it's in the favorites, and it has text and video. Now, if you want to do anything else on the screen, you have to copy that. So as a developer, I don't like to copy. So it's kind of natural to think about, okay, how we can abstract it. So one abstraction that you could create is a screen. You could check out Kakao Compose library that helps with that. It has some built-in nodes, classes that you could use, and you could do it in this way. So you have a screen, you define a test tag for that, and then you have a header, a favorite item, or something like that. Now, imagine the header is a merged component, so we need to unmerge it. You could use unmerged tree here, and then you could create a node for it specifically to access individual components, subcomponents. For the favorite, I said that we need to also match the section, but here we have just matching by the text. So I suggest we do the same, create a separate node for it so it's then easy to use. And then we also need to scroll to it because, well, it's a scrollable container, right? And depending on device size, it could be visible, it could be not. So not to be flaky, you have to scroll to the content before you actually use it. So then there is a way in Kakao to scroll, but you would have to have a lazy item provider or something, and then you would have to match it by index. And actually, Compose test rule, it provides this perform scroll to node using the matcher. So here you have to write a hacky way to get the matcher from Kakao and then pass it there, but it works really well, and I think much easier than a provider would. And then you can create these nodes. Now, I think in Kakao, the base node constructor is quite problematic because it has a lot of parameters in there. But what you can do is create then children of this node, and then it would be a title, a subtitle, and then you have, let's say, an item in favorites. So it works, but it's a bit cumbersome. So what we internally kind of created a wrapper and put every parameter in the node context, so we don't have to pass it all the time. And then now it looks much more readable. And then coming back to the test, you see this. So you imagine you have a function on, we talk about later, and then you pick the content, perform scroll to node header, and you can click on the title. And then you can also do any other checks that you would like. There are tons of checks in compose test rule, so I encourage you to read the documentation about compose testing. And you can also scroll to favorites, click on NVIDIA, what we wanted to do, right? So, and then the on function, it's just essentially we take the constructor of the screen that we defined, use the compose rule out of the base UI test. It sits in the base UI test. And then we also have a hacky way to integrate with Allure, so just log it as a screen step, so you actually see it in the report. And that's pretty much it, how you can set it up. The interacting and matching, I think it's a big topic, so I probably would like to refer to the documentation there. Now, network, and specifically mocking network. Why do we need to mock it? Well, because you cannot trust the backend anyhow, because even in normal operation, it sometimes doesn't work, and then especially on like staging environment. And then in the test, you need to be reliable and reproducible all the time, and sometimes you also need to mock an edge case, like let's say your account is blocked, right? So it's really easy to then mock it compared to wait for the backend folks to implement the setup for you so you can change it in test. So how to mock it? Well, we use awk HTTP, as I think a lot of people. So there is a mock web server library there. By default, it has a queue dispatcher, so you can add your response in the queue, and then it will respond with it. Problem with that, you don't control the order it gets requested. So the basic queue only works in the small-scale integration test, not for UI testing. So for that, I propose, okay, let's create a registry. All of the requests and their responses, so it can match them and respond with something. So for that, I propose kind of a DSL. So let's say you have an interface for requests, interface for responses. So then you can define all of the possible things in there, and then you have this function mock request that gives you this registry, and then you can run. You can use this DSL to create it. So far it's just JSON in there, so not a lot of things that you can do. So let's add a method to add the request. And let's take a look here. So we have a path that you can match your request by path and then return some response in Lambda. What is it times? Times essentially is sometimes you need to respond only once, and then you don't really want to have a mock afterwards, kind of clean it up. Or it also checks that you don't consistently keep requesting the things, and otherwise it would fail. And as well, sometimes you need to mock a success one after resolving an error. So like to test the retry logic, it makes sense to have the same request twice, but first fails and then another one is successful. And if you think about it, just matching by path, it's very limiting. So you can add another one that you have essentially a list of matchers that you can provide, that in combining all of them, you would find a match for your mocked response. And using Kotlin, you can have a default parameter and a lambda, and as well as vararg, and it works pretty well. As well as I usually have an always constant here, so if you want to always respond with something, you can just set it using this constant. Now, what is a matcher? A matcher essentially is just a class that, given the request, it says, hey, it matches or not, right? It makes sense. So now, one possible matcher could be a path matcher. So you can create an extension on this request registry, and then you can create a matcher for the path. Now, you can just take the path that you provided with the parameter and then compare with the actual request. It would work, but this API is still not perfect because you can abuse it a little bit. So what I usually do is try to constrain it. So whenever you misuse it, it kind of guides you to like a better option that you might choose, and then it gives you a message, okay, you can do this instead, right? Why? Because if you have a path and a query in one thing, the query parameters, they actually can be interchangeable, right? So if you just match it using a simple equals, it wouldn't work. Now, a lot of the requests and responses are a JSON object, and sometimes they are small like this. So you wouldn't want to have a file for that kind of thing. Otherwise, you would have tons of files just for these small things. What you could do is just create a string, put it there. The problem is editing these strings is not really particularly easy, and I think it's a bit problematic. What you can do is create a DSL again to kind of have a builder for it. And then there are a couple of libraries that already do that. You can do that on your own as well, so which I think is a really good option. Now, using that, you can create your body matcher, and then you provide a builder using a JSON thing. Then, fun thing here, if you match a JSON, you would have to provide all of the JSON as it is in the request. Even though the keys might be sorted in a different way, you have to provide all of the keys. Now, sometimes it's not good, so we have this non-strict matching by default, and it's actually a lead code problem that you can try to solve yourself, which is essentially having a tree, have another tree, try to find if it matches or not. And let's talk about responses next. So for responses, you have a separate interface, so you can have all of the responses neatly organized. And let's say you have an error response, or you have an asset body, so you just read it, a file from assets and respond with it. So imagine you have a read file function that just takes the context, takes the assets, and reads the file. That's pretty much it. Now, you can also use the same JSON builder to quickly respond with some small JSON. And you can also do it with the array as well. And then my favorite is a template. So essentially, you have a file, you read it, and then provided this small JSON, you replace a portion of it. So if you need to just change this small field in the JSON, but you don't want to code it in a DSL, you can just save it as a file and then change one bit of it, which I think is really powerful. Now you can be creative and create a lot of different responses that works for you, but let's take a look how it actually would be used in the test. So you have this mock request function, call it, and then you can actually call request, provide your path, and let's say asset body. You can choose this template that I was talking about, and just provide, again, the path, and then user, you would be replaced with this JSON object. And now you can also mock all of the rest things that you need for the test. Let's say you want to add a query parameter for an ID of instrument, return NVIDIA data there, and then you also want to match a post request for actually doing something with it, like adding or removing from favorites. Now, to interact with the screen, you would do this. You would just, okay, let's scroll to favorites, click on the favorites, item NVIDIA. On the header, on the instrument screen, you click on following, essentially unfollowing it, and then go back, and then you check that it doesn't exist anymore. So simple as that, but you actually have now a test that touches multiple screens. It has different API mocked already, and it's readable in a way that is like naturally you can follow what's going on in the test. Now, we also use WebSockets. So using this structure, you can actually mock, let's say, your WebSocket responses, but it's really depends on your protocol that you use. And I'm not gonna go into details here, but you can just have a separate registry for your WebSocket and have those matches that make sense for your WebSocket protocol, and have a separate extensions and so on. So it's be like kind of separated. But we have a default request matching in the registry itself. So if an app requests for the socket, it always connects to the same thing. Now, the dispatcher itself, it's a kind of sample implementation. It's not full. just because to fit it on the slide. And essentially, you can think about it as a queue, or in this case, it's a deck of handlers. And then whenever you kind of create this request, what you do is just take all the matchers, put them into a list, and then save them as this object that keeps track of how many times you actually requested it, and then responds that it needs to respond with. And then you synchronize, so you don't have any problems with concurrency here, and then add them to the queue, which is simple. Now, to respond with it, you just check the list of handlers and say, hey, actually, would you handle this request? If you would, then you check if you need to remove it, and then you return it, right? So now, if no handlers actually wanted to handle it, then it's not mocked, right? So then we can just return error, and then that's it. In the real implementation, we have also tracking of unmocked requests. So instead of just returning, we also keep them in a separate collection. So then when the test ends, we also log it and let users know, okay, you forgot maybe to mock this one, or maybe it's just not needed for the test. This is how network mocking works. So for stability, I tried to avoid it before, because, I mean, if you think about it, if you need to wait until it loads some data even from the mock server, can be a bit flaky. And then you kind of go multiple screens, you navigate, still can be flaky. So you have to think about stability in the first place. But you didn't see any idling resources or anything like that before. So, and the tests, they are inherently flaky. Sometimes you just, you didn't touch it for a week, and then suddenly it fails all the time, right? You need to write them in a way that they are kind of more stable. So how to do that? Well, you need to be aware of the common sources of flakiness. So I think the biggest one is the screen is just not ready. It's still loading some data, and maybe your validation is still working on something, or it's just asynchronously tries to render it. So for that, you can use a wait until interceptor. We'll get to that in a minute, but other sources are, like, imagine it's not visible on the screen. Well, probably you need to just scroll to it. So using this scrollable node, it kind of forces you to think about scrolling all the time, and then you kind of understand how, okay, if it's in the lazy column or a scrollable column, you always have to have the scrollable thing in your screen. Now, if it's a device-specific state like clock, permissions, or anything like that, well, there are rules that can actually mock your permission, like grant permission rule, or probably already inject clock in your code just to help with the unit testing, but you can also provide a test clock that would always be the same across UI tests. And then sometimes you have unstable code, because UI testing clicks really fast. You cannot click faster than that. So it just goes on to your screen and then does the actions incredibly quick. So then you find race conditions with it. So for that, you just fix them, right? I think it's a good kind of thing to be aware of, that sometimes it's not the test, it's the actual code that you try to test. And that's why we have them. And sometimes your CR runner freezes, and you just need to be kind of aware of that. If it happens often, maybe you need to fix somehow your runners. So one common thing that we had with our runners is it's machine, right? So sometimes you run Gradle on it so much, it just takes the whole disk space. So you have to sometimes clean it up. And there's no other way around it. So this is the kind of a sample test that runs on the app. So on the left side, we immediately respond with a response. On the right side, it takes a bit of time before actually responding. But without changes to the test, using this wait until, both actually succeed, even though they wait a lot, right? So, and sometimes it's just on the runner, you have concurrent processes working on the same CPU, and sometimes they just hang for a bit and then come back. So it might be always good to have some wait until, right? So what is the wait until? I think we use Kakao, right? And then there is another one library called Caspresso, which is on top of Kakao. We didn't use it because we already kind of built something on top of Kakao. But you can take a look how they use the wait until. We use is exactly the same algorithm. Or you can just take the Caspresso and test it for yourself. Yeah, I see you taking a picture. Go for it. So then, how to integrate with Kakao? Well, there is an interceptor, right? And it kind of works like this. You intercept all of the things. You can intercept individual views, but in this case, we just intercept everything. And then if we do the check, we just log it into Allure using the step function. We have this describe function that tries to take the description out of compose, and then afterwards do the wait until. So funny thing here, before actually retrying, you have to refine it. What does it mean? It means that you try to do something and then compose, let's say it's a lazy colon, you didn't have the view yet in there. So there is no semantic node found before. So if you try to retry it, but it's not there, it will just keep failing. So you have to refine it and refresh essentially the tree that you have. Same thing for actions. And I recently added this click workaround. So basically, when you click, probably you don't want to click on disable button, but by default, compose test rule actually does it. And we have to do this, like assert is enabled, and then assert perform click. So here is just you inline it here, and then it will always be checking for assert is enabled. And you do the same wait until thing. So the describe function is still work in progress. It's just a bit of a human readable thing that you can do. But it works so far, so let's see how we can improve it later. For infrastructure, I think it deserves its own talk, so I'm just going to briefly cover what we use, so you can get like a sense of what we do. So we tried Firebase. With Firebase, you need to have, basically you can just check one device at a time, so you cannot scale it that well. You have to prepare it and so on. So what we wanted to do is run on the PR, and every kind of change that you make to PR, run UI tests, and then have the fast feedback so we can actually be sure that we're not merging, like breaking changes. And then we kind of looked at the Marathon Cloud, which is a really good cloud solution for running UI tests, and there is a good documentation, very extensive, you can read how to set it up and so on. The same is for emulator WTF, but Marathon Cloud is also works for iOS, if you're interested in that. And it also has a kind of open source runner that you can actually use for free. And what we ended up doing for our scale, cloud is not really necessary, and we have some machines that we could actually use. So we just have some bare metal in the cloud provider that we run the emulators and can run tests in there using this CLI tool. So far it works, but other than that, you can also try to set up your own machine in the office, but then somebody needs to check if it's on and like sometimes reboot it. So maybe not a good idea. So I don't know, let me know how you do it if you run them. So far we started in October, and now it's already past June, and we have more than 400 tests. And if we keep going, it means that we would have to have a really dedicated data center just to run it. But so far it works for us with the current kind of scale. And you see how it kind of goes down a little bit in the terms of incremental number. So the time, I think it's pretty important to discuss. So with the full run, it takes 55 minutes. Just wait for it, and then it fails. Well, now you have to fix something and then wait another 55 minutes. So not a good experience, I would say. So we got it down to 25 using affected modules. So essentially what we do is we try to map the module to the test that actually covers this module, and then we can, if you change it, then it makes sense to run tests for this module, right? If you didn't change it, then maybe you don't need to run it, right? So I think this one deserves also its own talk, so I'm going to try to push my team to kind of present on that, which I think could be really fun. But this is it for infrastructure on my side. Now we talk about reporting. And this is the last one, so bear with me. So we use Allure test ops, as I said, and there you can also store your reports for automated tests. And then we use AWS S3 when we need to store individual PR runs, just for the budget saving. And then we also parse it and then put it in the GitHub message, so you know, okay, some of the tests were flaky, but they passed, for example. I mean, but maybe you need to take a look there. And sometimes they fail, you can open the failure reports and see it quickly here, or open the report and see it from there. And then what we log there is screens that I've shown before, actions, assertions that I showed you in the interceptor. Then we log, of course, the failure message, exception, screen. We do the screenshot when it fails. We dump logcut in there. And there in logcut, you also see requests that were not mocked. So maybe sometimes you change the API path, and then you need to update the UI test as well. We log the semantic tree, both merged and unmerged. So if you cannot, it says oh, it's not in the tree, I couldn't find it, then you can quickly refer to the tree itself and see was it there, or maybe the matcher is the problem. And also you see the history of retries, so you know if it's flaky or not. And it's still work in progress. So if you take, it turns out if you take the description out of matcher, it looks something like this. So essentially it's just because you have and, it just puts it in one giant string. So not very readable, but very, very verbose, but at least you get the idea of what's going on. So we want to improve on that. So if you have any ideas how to do that, I welcome them. And let's end the talk with the key takeaways. So first, I think it makes sense to design your test for reusability. So you could actually, it's a code, right, at the end of the day. And then if you write it like in a YAML file or something, it's not going to be reusable as much as actual Kotlin code. And you have to mock backend and find the right solution for you. So that could be this registry. And then you need to also think about how you're going to optimize, because if you just let it go, it can quickly add up, and then it would be more than 1 hour. So nobody wants to wait 1 hour to merge things. And this is it for this talk. Thanks for listening. And if you have any questions, please go ahead.